In this video, I'll talk about distributions which are closely connected to normal distribution. These distributions are very important later in statistics and we will use them in examples, but now I'm not going to give you any examples only. I'll explain only the definitions of those distributions. The first one is the log normal distribution. And we said that the random variable has log normal distribution, and of course with parameters mu and sigma squared, if some random variable y, which is logarithm of your given random variable, has normal distribution with this mean and variance. And in this case, the probability density function of this log normal distribution is pretty similar to the density function of normal distribution. You see the difference only that here we have logarithm and we have one additional 1 over x as a factor. This is because of the differentiation. And log normal distribution is defined for only non-negative x because we take logarithm here. Okay, and the cumulative distribution function of it can be found as follows. This capital Phi, remember, this is the cumulative distribution function of the standard normal distribution. And the mean and variance of the log normal distribution, of course, are found using E. So here is the mean and the variance. The next distribution that we will need is the chi-square distribution. And the chi-square random variable has always this v parameter, which is called degree of freedom of the random variable. So when we talk about chi-square, we always talk about degree of freedom. And this random variable can be obtained if we take v independent with standard normal distribution random variables and we sum them their squares. This will be the random variable which has chi-square with v degree of freedom. Okay, and a chi-square distribution with v degree of freedom in fact is a gamma distribution with parameters a half and kv over 2. And so it has expectation v, right, and variance 2 times v. And the notation for this chi-square random variable usually is the following. This is he, this is Greek letter, v squared. So this means chi squared with v degree of freedom. Let's move on to the next one. The t distribution. T distribution is the random variable which we usually denote by tv, and again we have degree of freedom here denoted by v, and this is the following. At numerator we have random variable which has standard normal distribution, and in the denominator what do we have? Square root of the chi-square distributed random variable over v. So, and this normally distributed and chi-square distributed random variables must be independently distributed, so they must be independent. And this t distribution has similar shape as the standard normal distribution, but a little flatter. And if we take v too large, this thing will approach to 1, and everything will approach to just normal, standard normal distribution. Okay, and finally, the F distribution. The F distribution is the ratio of two chi-square random variables which are independent. And what do we know about this F distribution? It has a positive state space and expectation close to 1, so at least almost 1, and the variance will decrease if we increase these two degrees of freedom. Okay, so again, these distributions are just given to you here, and we will use them in statistics later.